Hello guys, this is the last laboratory video in EE542, and in this video let us go through the whole instructions step by step together, and I think this will be a long video. And for the first step we need to do is to go to the multi-tag xDot official site to download the small demo, which is the Blinky, which is the embed OS example Blinky. This link is already invalid now, so we can directly Google it. Embed OS example Blinky. And we use this one. We use the embed OS example Blinky in the embed official site. And to compile it, we can use the local compiler, but it will download a lot of things like maybe more than 10 gigabytes or more. We need to install a lot of things. So we decide to use an online compiler, and we still have two choices. The first one is to use a legacy compiler, which is this one, but it is deprecated, and although we can still use it for some projects, but others do not work in here, and so we choose to use this Kale Studio, and it is recommended by ARM. Let me log in. I think actually I have forgotten my password, but don't worry. Why it is so slow? Never mind. Let's see here. But yeah, let's hear. Oh my god, it's stuck. Oh, it works. Okay, great. And we can modify one of the files, which is here. We can modify this file. You can see this blue bank, and this is a green bank. We can send something through the debugging port of the xDot, and we can use this one, change this interval of milliseconds so that it will maybe blink once per second, or for other intervals, and and then we can click on this button, this build button, and after building this, we can download a new file. And I have already compiled it and downloaded it, which is I have downloaded several versions of it. The difference between them is the just the time intervals, and for this file it will blink, the xDot will blink once per second, and for this file it will blink 50 times per second. And I just copied this file into my xDot, so I have to install this file into the xDot. I have to first install the xDot drive. The driver. I have already downloaded it, which is here. We have to install the embed Windows serial driver so that our Windows laptop can recognize the xDot. And after installing it, I insert my xDot into my USB port, and then we can see it here. And we also need to check the device manager. Wait a second. We also need to check the device manager here and look into the ports and this one is the debugging part, and this one we will use this later for as the AT command instruction part. And we drag this file into our xDot, and it will be installed automatically. And then we start the PuTTY, or here I use a mobile xterm, and after the LED light is stable, I slightly press the reset button on the xDot development board. I press it now, and then I try to connect the debugging port through the mobile xterm. Let's see. This is COM5, so I connect to COM5, and you can see that we can already receive the message that we wrote in the Chaos Studio here. This one we can receive it now. And one thing we need to pay attention is that we have to set this baud rate in accordance with the one in the device manager. Let's see here, and I set this to 9600. And on the other side, we have also set this set the baud rate in here the same as that, 9600. And I think this value is defined in this project somewhere, but I'm not sure. The reason I use 9600 is that actually, truth be told, I have tried 115200, but it didn't work, so I have to use this instead. and it is easy to deduct it that it is rather obvious that that value is written somewhere in this project, and then I'll show you later that we can change that value. And this is the first part of this laboratory, and the second part is to use some sensors to weld it on the xDot, but our sensor are still on the way, so we have to skip it. But I think I will still go through this part again when we are doing the final project. And this the second part, after doing the first part, we have to first install the AT command firmware, and we still have two ways to do that. The first one of the two is to compile it. It's rather the same. Is to compile it here. We still use the online compiler, and then we download it and to just the same thing as this application. And we just the other choice is to download it directly from the official site of the xDot. And let's see, I think we can find it somewhere after all. Oh, it's here. It's on the GitHub, right? It's this one, and I downloaded it, one of them. You can see the version is 4.4.0.5 and 6.8.0. So if we use the KO to compile the AT firmware by ourselves, we have to pay attention to the library version to make the version of the two libraries the same, or at least compatible with each other, or else it cannot be compiled. And that's one of the reasons we directly download it from the official site, because after all they are the same. And we have to do the same thing as the previous application, which is just to drag this AT command firmware into the xDot, and it will take some time to flash it. and after flashing it where the LED light on the xDot is stable, we again press the reset button. I press it now, and then I think we can use the AT command, and this will not work any longer. I mean, the debugging port should not work because I just flashed the AT command firmware, so AT command should work this time. And to connect to the AT command firmware port, I need to use COM3, and now I connect it to it, and I try AT command, and and it returns an OK. And one thing we need to pay attention is that we still has to be careful with the baud rate, and this time the baud rate is 115200, and the same thing is we still need to set the baud rate here in the device manager to make sure at least they are the same. And the next thing if we should do is to use the AT command to let the xDot join the LoRa network. I mean, we have to use some AT command to do that. And it's here. And before doing that, let's see the LoRa for some time. And to join the LoRa network, we have to set up the LoRa first. And the first thing we did is to reset the LoRa by pressing the reset button for more than 30 seconds, actually for 1 minute or so. And after doing that, we connect the LoRa physically with to my laptop with the twisted pairs, and then I go to the 192.168.2.1, and then we can see some interface like this, and the username and the password are both admin, and we press enter, and we skipped some introduction steps so that we can keep the original username and the password. And one thing we did later is to let the LoRa connect to the external internet. I mean, the LoRa can only connect to our local network now. So we have to remove the LoRa from my laptop and then insert the twisted pair to our home router. And we didn't use the USB micro USB to connect the LoRa to my laptop. And then I found that I can use SSH to control it. So this is LoRa, and I have configured some DNS server, and you see this one. This is my home, the IP address of my home router, and config-8. You can see that I manually assign an IP address to the LoRa, which is .0.101, and I also set the default gateway. I also set the default. I also set our home router as the default gateway of the LoRa. This is the IP address of our home router, and I also set an DNS address. And after doing this, I just use I just use this to set a static IP address for the LoRa to use. and then I go to the settings of our home router. This is the main page of our home router, and I log into it. And you can see one of our device, which is this one, is connected with the wire to our home router. And if you cannot see this, actually we could not see this originally, so we configured manually. Let me check here in DHCP server, and I keep one address as the reservation for the LoRa, and I click on save, and this is activated, and so that our TP-Link home router can detect this device. And now our LoRa can connect to the public internet. Let's try locally first. I will try my this is the IP address of my laptop. I'm not sure actually. 1 sec. Let's see. Yeah, this should be my laptop, but oh, never mind. Yeah, it works. This is my laptop, and now let's try another outside name server instead of an IP address. Let's try google.com, and it works, right? And now we have already made sure that the LoRa can also access the public internet, but that is not the important thing in this step, but it is important in the later step. After all, we have to upload all of the data into the AWS, which of course needs the public internet access, right? And let's continue. And the next job we need to do is to configure the other thing of the LoRa. Let's log in first. And we go here. We enable this network server, and after we enable it, we can see the status of the network server is running. It's green. This line is running, and we set the frequency subband as 7, and we set the network mode as public LoRa band, and we also set the join delay as 5. And after that, we click on submit, and then we click on this. We choose we set up a local keys, and I named it anti-sleep, which is the name of our team. And after that, I think we also start the Node-RED by clicking on this button, and it takes some time to finish setting up. And after setting up the Node-RED, we can see something like this, and we'll talk about this later. And now let's go back to the xDot part. And after I flashing the AT command firmware, let's try some AT command to see whether that firmware works or not. And we set AT plus NI is equal to 1, and anti-sleep, and AT plus and k is equal to 1, anti-slip, and AT plus frequency sub is equal to 7, and AT plus JD is equal to 5, and AT and W, and ATZ, and AT plus join, and this step will take some time. AT plus join. Oh, what happened? Oh, let's try again. Never mind. AT plus join. Yeah. So now the xDot has already joined the LoRa's network, and then we can use AT command to send some debugging message like this to test whether the AT firmware, the xDot, and the LoRa can work together. And I paste it, and let's first go to the xDot, and I think we can see the message here, and we click on this and click on deploy, and yes, and by the way, let's see the let's see the structure of this graph. I just drag this LoRa, I drag this, and then I drag this debug, and I activate it, and let's see. I now press the enter so that I can send the message. You see that it is received, right? And you may just pay attention to this part now. And this message is displayed by the first debugging model, and let's ignore the second part and the third part for now temporarily. And you can see that the AD command can work on our xDot, and the xDot and the LoRa can work together. And after doing this, we come to the next step, which is to modify to writing C++ program and trying to send some data to the AWS. Actually, this data is the this part is the temperature, but we don't have the sensors now, and we have to send some dummy data for now. And the dummy data we chose is something like this. Let's see. We use this program. Go to SRC and OTA example, and yeah. So previously we have to set the parameters like the frequency subnet and the join delay, like this into in the AT command serial. And now we have to do everything in the with the C++. In this compiler, and the network name, which is here, the first one, which is here, we have to set it here, and also the passphrase, which is the second one, we have to set this in this program, and frequency subband is equal to 7, which is the same, and the join delay is equal to 5. And we just did some small modification to this program, and let's see. Whether I can still find it. Oh, here. And we continuously send this string as the TX data to the LoRa from the xDot. And after this modification, we still click on this build button. We still click on this build button, and we can get something. We can download something from this web page, which is like which is like what? Which is like this. This file is still a large file for the xDot, and I still copy it. And this flashing. And after the LED light is stable on the xDot development board, I selectively press the reset button, and I press it now. So now the xDot should work in the as expected in this code, right? Which is continuously sending this string to the LoRa. And actually we can remove the xDot from our laptop, because now I just insert the xDot USB into my laptop, and now I can remove it because it just needs some power. It doesn't need the data transfer through the USB port. And now I remove it. So 1 second. And I plug it into my adapter. The power adapter. Oh. And it needs some time to start up. And now we go to the xDot of the LoRa, which is here. And let me clean this. And what we received now is something like this. And you can see that there are some strange characters appended after our correct string. Sometimes, yeah, you see, this is after checking the raw data, I found they are actually reverse slash 0000 reverse slash U000 or something like that. I don't know what that is, but let's just get rid of them by in this step. So I drag an function step which is here, and I use the split function to get rid of the character like this, and I only choose the first part. So after doing this, I only keep the first part, which is EE542 anti-sleep, and I'm just simulating the data processing by adding a time. And after this step, the message becomes a JSON string, and let's see what will happen. And now you can see that the string is name, which is correct. You cannot see the strange characters now, right? And and I also added the time. So that's what it looks like. And the final step is to add an HTTP request model, where I just drag this model here, and we have to do something extra in this step, because if I want to send something to the AWS through the MQTT test client, we have to set this step, right, which is enable secure connection. And first let's deactivate this. And in this step, we have to choose the certificate, private key, and CA certificate. And one thing which is the limitation of the LoRa is that the Node-RED can only access some specific folders in the LoRa. It cannot access to anywhere. I mean, if I just 1 second. Let's just try to connect the xDot with SSH. And I mean, if I just copy everything here with SCP with this command. Oh, never mind. I mean, if I just copy everything with this command, it doesn't work. It will not work. And I found that I should only copy everything into this folder, which is /user bin. I need to copy everything here. You see that this is the private. This is the private.key. And this is the Amazon root c1.pam, and you can also see a certificate which is here. It needs the 3 files, so I copied everything here with the scp command from my laptop to the LoRa, and I configured them here, and I also copy this subscription endpoint link. I copy this and paste it here, and I also add a port and my topic, add a topic, so that I can subscribe it into in the MQTT test client. And after doing this, I click on the deploy. So I will just deactivate those debugging message, and I activate this one, and I click on the deploy button, and it takes some time to see the response. And let's see whether it works or not. Yes, it receives the response, which is okay like this. And on the other side, I will just clear everything. And after some time, we can see some message in this web page. Yes, this you can see it's the latest message. And that's all part for this laboratory. And let's see whether I still have something didn't tell. Yeah, that's the all part. And if I want to set up ThinkSpot, it will be easier than this, because it doesn't need private key or certificate like this, right? It doesn't need something like this, right? And that's the part of this our last lab video. Thank you.